Hey, welcome to the new video of the Mastering Concurrency playlist. Today I'll be solving the very second problem. The first problem, which we have already solved, we can get through it in my YouTube channel. Today we'll be solving FooBar Alternative. It's a part of a concurrency playlist, which is the sequence, which is a set of 12 questions by LeetCode itself. And we'll be solving the second one, that is FooBar Alternative. So what the question exactly states is that they've already given us a class named foobar, and within this we have two functions, foo and bar, and they'll also be giving a input an integer. Uh, this indicates if n is equal to 2, this function will be triggered n times. Both the functions will be triggered n times basically, but the order is not defined. So that both the functions can be triggered in any order because we will be triggering from I to n both the function, but that can be triggered in any order. But whatever might be the order, the output should be foo and bar. So even if first n times the foo functions has been triggered and next n times the bar function has been triggered, in general the output will be n times foo and n times bar, right? But here they're expecting us to be alternative, foo and bar alternative. Anything may happen. I need a foo before a bar. That's what the question states. So again, we can solve this using many approaches are there. Semaphore, mutex, and many other approaches. Atomic integer, we can solve in any approaches in Java using multithreading. So in this video, I'll be solving via uh, Semaphore. So also I'll be showing you the interactivity of the thread. So if I go to the course, the second one, FooBar Alternative. So yeah, I'll be writing the code as well as I'll be explaining the visualized form, how the thread works in the background, right? Yeah, I'll be declaring the semaphore. I need two semaphore basically, one for foo and one for bar. Similarly, I'll be declaring two semaphore. Uh, Let us name this as foo semaphore and one more semaphore for bar. And in my constructor, I'll define this foo semaphore is equals to the new semaphore. Let us keep it for 0, 0 now. I'll tell you the edge case. That time we might change the foo semaphore's initial value, 0. Now, the interesting part, when to acquire lock. So two functions will be running. I have print foo will actually print the foo and print bar will actually print the bar, right? So when I can acquire lock, I can acquire, I can only print bar when I already have a foo already written. So when a foo function has been executed, I'll indicate that next bar can be executed, right? So I just mention BS to be released. This indicates I can now print the bar. But just before printing the bar, I'll again check, was bar acquired? If it was acquired, I cannot go ahead and I'll wait for foo to be printed. And after bar has been printed, I'll for the next iteration, I'll again tell foo, you can go ahead. Foo thread can go ahead. So that will be, but just before the foo function, I'll also check if there was a release by bar. So foo and foo cannot be one together, right? I need foo and bar, right? So I'll just check, can foo be printed now? For that, I'll acquire one more luck. So now, yeah, it's perfect. But there is one catch. Any order, I just need foo to be printed very first time, not bar. Even though it's the alternative, even bar and foo can be there, but I need foo always to be given the very first priority. So I'll just indicate my foo thread to be 1. This indicates this will skip the very first initial locking mechanism. when I was 0, this will skip, so that I always get foo bar, not bar foo. So that was one of the edge cases. And yeah, this was the code. And if I show you the interactive way how it works, initially I'll reset it. Initially both i- initially foo is 1 and bar is 0. Similarly how I was made initially, the foo thread is 1, bar is 0. And again, if I trigger bar, it's not actually, it's still blocked, right? Why it's blocked? Bar has been blocked because it has bar dot acquired. Uh, so when bar has been acquired, I'll just check the value is 0. The lock will only bypass if the value is greater than 1, sorry, greater than 0. Initially, the value is 0, it's not getting bypassed. So when will this get bypassed? When I make a release for this. So when the release happens, it's happening in foo function. So now if I trigger a foo thread, it will, and foo thread initial value is already 1. So this lock will be bypassed, right? And this will print and it will release. So if I trigger foo got printed and it released. So the value also of bar now is 1. If this is 1, then this log got broke. Base.acquire happened and this log got broke. Now it's showing me the green that indicates I can trigger bar. If I trigger bar, this function got called. fs.release happened. That indicates again my foo got 1 and bar got printed. So again, I can keep on juggling between foo and bar and the output will be common. So this was it. I'll be uploading the Golang solution also, and I'll also be uploading the next set of solution for all the problems. Yeah, keep tuned.